Okay, welcome back. This is quite possibly the most important lesson that we're going to do in this first topic A, but also the most confusing. So we are analyzing graphs. This is a lot of guesswork, which is why it's the toughest. So this says water consumption in a typical school day. So if you keep reading, and we're going to do number 1, so I'm going to leave it right there. It says the bulk of water usage is due to the flushing of toilets. Every single flush takes 2.5 gallons of water. Samson, strong name, love it, estimates that 2% of the school population uses the bathroom between 10 and 10:01, which we're going to assume is this spike. Okay, that's 2% of the school population. What is a good estimate of the population of the school? So, first off, we need to know what these numbers are and what these numbers are, because it does not state that. That's part of the problem. So if each flush uses 2.5 gallons of water, these are not flushes, these are gallons. What is this? This is our time. So this is the gallons versus the time. So we're not looking, it's not water flushes per day, it's the water consumption. So how much water is actually going down our drain, which is determined in gallons. That's how I knew that. So here we are at this, and it's hitting 80. So there are 80 gallons going down. Okay? So what we want to know is how many times was that flushed? Because most people don't go in the bathroom, and I'm saying most people, hopefully not. Most people don't go in the bathroom and go flush, flush, flush. Let me go to the potty, flush, 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 flush. You go to the bathroom, you flush it. I mean, most normal people do that. So we need to divide the gallons by the gallons per flushed. So when we take 80 divided by 2.5, I want to say we get 32, but I'm going to get my handy-dandy calculator. Give me a second. Don't worry, I'll sanitize it after I get done touching it. This is why I need to get my own calculator in here. So 80 divided by 2 and 5/10 gives me 32 what? And that's the question. It's not just 32, it's 32 flushes. Okay. So the question is trying to get us to say, hey, how many students of the 2% are there? Well, if there's 32 flushes, we can assume, and again, this is that guesswork, that right here, 32 students used the toilets. Okay, so now that we know that 32 students use the toilets, now we can start to go back to last year where we talked about percent over 100 equals part over the whole. We want to know the total number of students in this school. Only 2% used this. So remember, the equation that we used last year was the proportion part divided by whole equals percent divided by 100. So now I can say, okay, the part is 32. I do not know how many students we have. 32 at that 2% equals the percent, which was 2 over 100. Cross multiply. 100 times 32 equals 2x. 3200 equals 2x. Solve equations. Divide by 2. X equals 1,600 students. So now we have a good estimate for the number of students at our school, which is 1,600. Okay, so the next question that it has, I'm not going to go there yet. Samson then wonders, if everyone at the school flushed the toilet at the same time, how much water would go down the drain if the water pressure of the system allowed? Are we able to find an answer for Samson? So what I'd like you to do is, now that we know how many students, you can come up with question 2. So I'm going to leave this work up there. I'll put question 2 right there for you so you can read it. Samson then wonders. So pause it, see if you can come up with an answer of how much water the whole school would use if everybody flushed the toilet at the same time. Go. Well, personally, I think this one's pretty easy. We know it's 2.5 gallons every flush. If we've got an estimate of 1,600 students, we multiply that by the 2.5 gallons, so that's 0.00380000000. That leaves me with 40,000 gallons. I hope I'm right, I hope I'm right, I hope I'm right, I hope I'm right. Nope, I missed the math. I missed math somehow. 5 times 0, 5 times 0, 5 times 6 was 30, carry the 3, that's good. Put the 0, 0, 0, 12, carry the 1, 3, 0, 0, 0, 0. So why do they have 4,000? Wait a minute. 1,600 times 2.5. Am I just doing my math that wrong? Oh my goodness. 1,600 times 2.5, 4,000. So I'm just doing my math really wrong. This is why you guys have calculators and I'm not back in school yet. And I need to get my brain working. Oh, that's why, Mr. H, you silly goose. I did get 40,000. And if you were watching, what did I forget? This decimal. That decimal has to move over. So that leaves me with 4,000 gallons. And yes, I absolutely made a mistake and I will keep making mistakes, and that's why I leave them in the videos, because I want you to see that I'm very close to perfect, but I'm not perfect. So if you just give me 4,000 gallons, I don't want that answer. It's a word problem, give me words. How much water would go down the drain? 4,000 gallons of water goes down the drain. Okay? Basic. Those were basic math problems. All of that was able to be done with actual calculations. Now it's where we get into the guesswork that it becomes a little bit shadier. And yeah, I just used the word shady. That's right. Math can be shady too. Anytime that we are guessing or making a hypothesis is where that guesswork can become troubling. Make a guess as to how many toilets are at the school. Well, sure, make a guess. So we know, and here's how I would do this. If there's 1,600 students, we're going to need quite a few toilets, okay? So it doesn't really matter. Are we going to need 1,600 toilets? No, okay? Let's think about our own school. There's about 400 students in our school, okay? If there's 400 students, let's think about the number of toilets that we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 toilets for 400 students. Okay, so 10 for 400. Let's put an X and make 1,600. Why can I do that? I'm only doing that because that's how many toilets I know that we have in our school, and I know the number of our building. So this is how I'm going to use my guesswork. So now I can cross multiply. I've got 400x. I've got 16000. I divide by 400. And that's going to give me x equals 40 toilets. Okay? So even though I'm guessing, I have no idea how many this imaginary school has, but we're going to guess 40 toilets. That could be wrong, that could be right. Okay? You do not know. That's the worst part about guessing. So now we've got question 3, 40 toilets. Make a guess as to how many students are in the school. Well, we've already done that, 1,600. And what percentage of students might be using the bathroom at break times between classes? Well, we know that right here, this was 32 students who used it. Here's the most, and this is about, it's not quite 100, let's call it 95. So we can do the same thing and say 95 gallons divided by the 2.5 gallons flushed. We might get a decimal, so we might have to round it. 95 divided by the 2 5/10 gives me 38 students. So 38 students were using the toilets between break. Okay? Again, we're all still guessing right now. Are there enough toilets? So, And what percentage of students might be using the bathroom at break time between classes? So what's percentage? So 40 or 38 students. So again, so we're going to do 38 divided by 1,600 to figure out the percentage of students. So we get 38 divided by 1,600, and that gives me 0.02375. So again, we know that that's a decimal. It's really by the 100, so we have to move it 1, 2. So 2, and let's round it up, 2.4%. So 2.4% of students are using the bathroom between breaks. Okay. So now we're going to estimate the number of students. We already did that, it's 38. Assuming each flush uses 2.5 gallons, estimate the amount of water used during the peak minute of each break. During the peak minute, well, we've already done that, so it's about 95 gallons. So the amount of water used during the peak minute of each break is about 95. What time of day do these breaks occur? Well, if the school varies, consider today's schedule. My guess is where those peaks are, these. Change of classes, maybe lunch. Maybe it's like what we have, it's an AM, PM schedule. So these students are getting ready to leave. These students are coming into the building. There's a bunch of different ways that you could say, why is this happening? And then draw a graph that could represent the water consumption in a typical day of your school. So our day is going to be a little bit different. So again, we have gallons, we have time, and I'm going to say, okay, nobody's in the building. Then I come in, I pee a little bit, I pee. All these people are using it. Then we've got a little bit more of a rise. There's the change of first classes, right? Then we've got a little bit more. There's the change of second classes. A little bit more. There's the change of third classes. And then it's just down here again for a while. Why? AM classes, the nice long hour break. Kids come in. Kids break, kids break, kids break. So again, this is all guesswork, but you can write all of these out to figure this kind of stuff going on. Now, are these questions easy? No. Is it going to take a lot of guesswork and you guys talking over it and probably arguing about them? Yeah, and that's all right. Okay? So you now have one more lesson before our quiz, because we're going to have a quiz on topic A, but that's it for now. Hooray!